Hey guys, welcome to the 2022 Year 9 5.3 Indices topic test. Here are the solutions. Question 1a, we multiply the coefficients, so 3 times 2 equals 6. It's multiplication, so we add the indices. 3 plus 4 plus 1 equals 8, so it's 6v to the power of 8. Question 2, we divide the coefficients, so 15 divided by minus 5 equals negative 3. And we subtract the powers, that gives us z to the power of minus 4. However, according to the question, we're not allowed negative indices. So we must move that z to the denominator, so it becomes negative 3 over z to the power of 4. Question C, we simply multiply the powers, that gives us h to the power of 18. Question D, everything that has a power of 0 gets replaced by 1. So d to the power of 0 gets replaced by 1. 10 does not get replaced by 1. 10 has a power of 1. 4d is all inside brackets, so all of that gets replaced by 1 because it's raised to the power of 0. And 2d, all to the power of 0, also gets replaced by 1. That gives us 10 plus 1 minus 3, which is 8. Question 2, only the x has a negative indice, so only the x gets moved to the denominator. That gives us 2 over x. Question B, the whole thing has a negative power. That means all of 5p gets moved to the denominator. That becomes 1 over 5p. Question C, once again, only the x has a negative power. So only the x gets moved from the denominator to the numerator. That gives us x over 2. Question D, all of 10x is raised to a negative power. So we move that whole thing from the denominator to the numerator. That gives us 5 and then 10x in brackets squared. So we can expand those brackets. 10 squared becomes 100 and then x to the power of 2 is x squared. Then we expand the bracket by multiplying. 5 times 100x squared is 500x squared. Question E gives us a fraction and it's all raised to the power of minus 1. That means the whole thing is just flipped upside down. So it becomes 5y over 3x. Question F, we get rid of the negative first in the power, so we flip that whole fraction upside down. That gives us 7k over 2w, all to the power of 3. Then we raise everything to the power of 3. 7 to the power of 3 is 343. K to the power of 3 is k cubed. 2 to the power of 3 is 8. And we have w to the power of 3 as well. Question 3 gives us fractional indices. So you can see the denominator is 4, that means it's the fourth root, and the numerator is 3, that means the power is 3. So it's the fourth root of x cubed. Question B, 6 is to the power of 1, because there's no power written there, and x has a negative power, so we're going to deal with the negative part of it first. We move it to the denominator, then we deal with the fractional component. 5 is the denominator of the power, so that's the root, the fifth root. And 2 is the numerator, so that's going to be x squared to the fifth root. Question C, we have 8p in brackets, all to the power of 2 over 3. We expand those brackets. That gives us 8 to the power of 2 over 3 and p to the power of 2 over 3. Putting 8 to the power of 2 over 3 in our calculator gives us 4. Or you can take the third root, which is 2, and square it. So that also gives us 4. And for p to the power of 2 over 3, 3 is on the denominator, so it's the third root, and 2 is the numerator, so it's p squared. Question D, we need to write it the other way around. We can see 8 is the root, so 8 will be the denominator. 3p is the power, so that will be the numerator. So it becomes x to the power of 3p over 8. Question E, we have x to the power of 5 over 3 inside the fourth root. So we can put x to the power of 5 over 3 in brackets, and the fourth root means to the power of 1 over 4. So we put that outside the brackets. Then we just simply multiply our powers. That gives us x to the power of 5 over 12. Question 4, we need to expand these brackets, so we need to raise everything to the power of 4. When you're raising minus 2 to the power of 4, you must put that minus 2 in brackets. If you don't put it in brackets, it will give you negative 16 instead of positive 16. A becomes to the power of 8 because 2 times 4 is 8, and B becomes to the power of 12 because 3 times 4 is 12. Simplifying negative 2 all to the power of 4 gives us 16, a to the power of 8, b to the power of 12. Question B, we expand the brackets on the numerator. That gives us 9m to the power of 14. And on the denominator, we do the division. So 10 minus 4 in terms of the powers gives us m to the power of 6. And finally, we have a fraction, so we subtract the powers. So that gives us 9m to the power of 8. Question C, there's many ways to do this, including simplifying straight away, but we're just going to do the numerator first and then the denominator and then simplify. So solving the numerator, we do 16 times 9, that's 288, and we leave all the pronumerals alone. So p to the power of 7, q to the power of 4, and r to the power of 4. For the denominator, we do 20 times 3, that gives us 60, and we leave the pronumerals alone. And finally, we simplify. Putting 288 over 60 in our calculator gives us 24 over 5. For the p's, we can do 7 minus 5, that gives us p squared. R to the power of 4 stays on the numerator because there's only one set of r's. And for the q's, we have extra q's on the denominator. So we have 5 extra q's on the denominator. So q to the power of 5 is on the denominator. Question D, we expand those brackets first. 4 cubed becomes 64. And we multiply the powers for x and y. So that gives us x to the power of 6, y to the power of 3. We leave the x squared y alone. On the denominator, we expand those brackets as well. 12 is not inside the brackets, so we leave 12 alone, and it becomes x squared y to the power of 4. Then we clean up our pronumerals on the numerator, and that becomes x to the power of 8 and y to the power of 4. And finally, we clean up everything to give our final answer. 64 over 12 becomes 16 over 3. For the x's, we do 8 minus 2 for the powers. That gives us x to the power of 6. And the y's, it's y4 over y to the power of 4. So they cancel, and it's just 16x to the power of 6 over 3. For question E, we're going to simplify the numerator and the denominator separately first, and then we're going to clean up the fraction. So 2 times 20 becomes 40. For the a's, we have 3 plus 1 for the powers. That gives us a to the power of 4, and it's just b to the power of 4. For the denominator, we need to expand those brackets. So 5 squared is 25, and for a, 3 times 2 gives us a to the power of 6. Leave 3b to the minus 4 there, and then we just clean up our denominator. So 25 times 3 is 75. Finally, we're going to clean up our entire fraction. So 40 over 75 gives us 8 over 15. A to the power of 4 over a to the power of 6 means there's a squared extra, but on the denominator. So a squared goes on the denominator. Now for the b's, you got to be careful here not to just simply cancel them away. We have 4 minus minus 4 for the powers. That means 4 plus 4, which is b to the power of 8. Question 5, we need to use some substitutions. So you can see here in the powers, it says 2x plus 1. That plus means a multiplication of the bases. So that gives us 3 to the power of 2x times 3 to the power of 1. A times because of the plus in the powers. Now we need to write 3 to the power of 2x in terms of 3 to the power of x. And the reason is the question has given us a substitution for 3 to the power of x. That means that we can write it as 3 to the power of x all squared, because x times 2 will become 2x. We don't need to do anything to the other 3 because that's just 3. Finally, we can replace 3 to the power of x with 5. So that gives us 5 squared times 3, and that becomes 75. Question B looks a little trickier. It's 8 to the power of 2x. Well, 8 is not useful for us. Only 3 and 2 are. So I can split 8 up into its prime factors, and it turns out 8 is equal to 2 to the power of 3. So I'm going to replace 8 with 2 to the power of 3. And the reason is I want the base to be either 2 or 3 for the substitutions to work. In this case, it's going to be 2. Once I do that, I can expand the brackets. That gives me 2 to the power of 6x. And just like in question 1, I can write that as 2 to the power of x all to the power of 6. And replacing 2 to the power of x with 7 gives me 7 to the power of 6. Question C is 18 to the power of x. Well, I need to split 18 up into powers of 2 and powers of 3. And I do that by using prime factorization, or factor trees. When I do that, I get 2 times 3 squared. So I'm going to replace 18 with 2 times 3 squared and leave the x on the outside of those brackets. Then I'm going to expand those brackets, and it becomes 2 to the power of x times 3 to the power of 2x. 2 to the power of x is fine. I can leave it alone because I have a substitution for that. And 3 to the power of 2x I write as 3 to the power of x all squared, and replace that 3 to the power of x with 5. Finally, I put it all into my calculator and get 175. Question 6, I simplify the numerator first. So 3m plus m is 4m, and 1 plus 6 is 7 for the powers. So it becomes a to the power of 4m plus 7. I leave everything else the same. And then I simplify that fraction. So I need to subtract the powers here. So I do 4m minus 2m. That becomes 6m. And I do 7 minus 5. That becomes 2. And finally, I need to expand those brackets. So 6m times minus 3 is minus 18m. And 2 times minus 3 is minus 6. Question 7 is a little bit tricky, but it turns out that if I have two numbers and the bases are the same, that means that the powers should be the same as well. So 4 is the same as 2 squared, so I can write that as 2 to the power of 2x. 1024, if I do my factor trees, it becomes 2 to the power of 10. So 2 to the power of 2x is equal to 2 to the power of 10. Because the bases are the same, that means that 2x is equal to 10, or x is simply equal to 5. I do a similar thing for b, so I do my factor tree for 81, and I get 3 to the power of 4. That means 2x minus 8 is equal to 4. I use my equations there to do a plus 8 and divide by 2, and I get x is equal to 6. Question C is a little bit more difficult. We need to write both of these in terms of powers of 5. So 1 over 5 firstly needs to become 5 to the power of minus 1, and then I need to expand those brackets. So it becomes 5 to the power of minus 7 plus x. On the right hand side, 125 becomes 5 to the power of 3, and then when I expand those brackets, it becomes 5 to the power of 3 plus 3x. Then you equate the powers, so minus 7 plus x equals 3 plus 3x. Bring all the x's to one side, bring all the numbers to the other side, and you get minus 10 equals 2x, or x equals minus 5. Question 8, we need to write these as fractions first. So q is to the power of minus 1, so it becomes p over q. And for the second part of it, p is to the power of minus 1, so it becomes q over p. Then we need to write it as a single fraction. So that means pq is going to be the denominator. So the first fraction I multiply by p over p, and the second one I multiply by q over q. That gets me p squared minus q squared over pq. Question 9, I just expand the brackets. So a half times 10 is 5, so it becomes p to the power of 5. 3 over minus 5 times 10 is minus 6, so it becomes q to the power of minus 6. However, it says please leave it as a positive indice. That means the q moves to the denominator, and it becomes p to the power of 5 over q to the power of 6. Question B, we're going to expand those brackets first. So we do 2 times 2 for x, and that becomes x to the power of 4. We do 5 times 2 for y, and that becomes y to the power of 10. We're going to leave everything else the same. Then we're going to clean up the powers on the numerator. So we add the x's, and that gives us x to the power of 12. And we add the powers for y as well, and that gives us y to the power of minus 2. Everything else we leave the same. Then finally, to finish it off, we simplify 5 over 10. That's a half, so we put the 2 on the denominator. For x, we do x to the power of 12 over x to the power of 10. That's x squared on the numerator. And y to the power of 2, we need to write that as a positive indice. so the y moves to the denominator, giving us a final answer of x squared over 2y squared. For question C, we have a look at that numerator. It's all to the power of 0, so we replace all of that with 1. For the denominator, x to the power of 0, we can get rid of that because that's 1. And we can write that as 1 over 81y to the power of 8, because we need to raise everything to the power of 4. On the right hand side, we leave 9 and y to the power of 10 alone, and we need to write x to the power of 3 as a positive. So that moves from the denominator to the numerator. And finally, to clean it up, 9 over 81 becomes 1 over 9, and for x, we leave it alone. There's only one set of x's. For y, we do 10 minus 8 for the powers, and we get y squared. Final answer, x cubed y squared over 9. Question D, we're going to use KCF. So I keep the first fraction, I change the division to a multiplication, and I flip the second fraction. I don't need to do anything else in that first step. For my second step, I'm going to expand these brackets. So 4 squared is 16, m squared all squared is m to the power of 4, and 3 times 2 for the n's becomes n to the power of 6. On the right hand side, we have 3 times 3 for m, and it becomes m to the power of 9, and 2 times 3 for n, and it becomes n to the power of 6. We can leave the denominator the same. Now we're going to clean up the powers of the coefficients. So 4 plus 9 for the powers of m becomes m to the power of 13. 6 plus 6 for n, and that becomes n to the power of 12. On the denominator, we have 5 plus 1 for m, and it becomes m to the power of 6. And 4 plus 5 for n, and it becomes n to the power of 9. Cleaning all of that up, we do 16 divided by 2, which is 8. 13 minus 6 for the powers of m gives us m to the power of 7. 12 minus 9 for the powers of n gives us n to the power of 3. Question E, I'm going to start off using KCF again. So I keep the first fraction, I change the division to a multiplication, and I flip the second fraction. I don't need to do anything else. Then I'm going to expand those brackets. So 5 squared is 25. 4 times 2 for the powers of m gives me m to the power of 8. Minus 3 times 2 gives me n to the power of negative 6. For the brackets on the bottom right, I do minus 1 times minus 2, that gives me m squared. And 1 times minus 2 gives me n to the power of minus 2. Now I need to simplify the powers. So I do that for the numerator first. I do 8 plus 1 for the powers of m, and that gives me m to the power of 9. I do negative 6 plus negative 4. That gets me n to the power of negative 10. On the denominator, I do minus 1 plus 2. That gives me m to the power of 1. And for n, I do 2 plus minus 2. That's n to the power of 0, so I can leave that alone. And finally, to finish it all off, I clean it up. 25 over 5 is 5. 9 minus 1 for the powers of m gives me m to the power of 8. N needs to move to the denominator, so it becomes positive. That gets me n to the power of 10. Question F, the first thing I'm going to do is get rid of that power of 0 because it's equal to 1. So I can cross that out. Then I'm going to expand all these brackets. 8 to the power of 1 over 3 is 2, and it becomes x to the power of 4 over 3 as well. On the right hand side, I have negative 3 to the power of 2, so that's 9, and it becomes y to the power of 2 over 3. On the bottom right hand side, I have minus 2 times a half for x. That gets me x to the power of minus 1. Next up, I'm just going to clean up those numbers a little bit. 2 times 9 for the numerator is 18. 2 times 3 for the denominator is 6. You can also just simplify there straight away. If that's easier for you, that's fine. For the next step, we're going to clean everything up. So 18 over 6 is 3. For the x's, I do 4 over 3 minus 1. That becomes 4 over 3 plus 1, which is x to the power of 7 over 3. And the y's we can leave alone. 3, we just put out the front because it's a whole number. It's not a surd. For the rest, we don't want to use fractional indices. We want to write it as a surd. So you can see there that the denominator is 3. So that will be the root. So we put everything to the third root. And the numerator will be the powers, so it becomes x to the power of 7, y to the power of 2 inside the third root. Question 10, you can see there that every single term has a power of x. So another way to write this is I'm going to put brackets around it and factorize by taking the power of x out. So if I write it like this, if I were to expand those brackets, you can see that I would get exactly what's written in the question. Now that I have only numbers inside those brackets, I can put those into my calculator and I get 36. So the final answer is 36 to the power of x. Thank you very much. I'll see you next time.